So this will be the acceleration of the body which is moving along some curve with r equal to a cosine of omega t I plus b sine of omega t j. So this, if this is the parametric equation, the particle is moving along this very curve. So for that we have to be cautious that the equation will be given by this, accelerated equation will be given by this. That means the acceleration will be minus times omega square r, and this is the equation of simple harmonic motion. You might have already seen it earlier also, because acceleration is proportional to the position vector r with a minus sign. Minus indicates that it is tending to retreat its path after with the passage of time. Okay, so here in this case it will be like the sinusoidal wave. Fine, so particle will be moving along this very thing, but it will be coming back with certain phase again. Then after it will be retreating its path. In time it will be following the sinusoidal path. Okay, so this very motion is the simple harmonic motion. That means the particle which was under consideration here, moving along this very curve, is actually following the simple harmonic motion, and the acceleration is given by this very equation. Now we are concerned with the force acted onto over this this particle P, which is following this very equation. So for that, to calculate the force, that is the equation A, applying second law, multiplying equation first with mass of the particle, that is m. Say this is the mass of the particle m here. So applying mass of the particle, multiplying throughout, we will get mass times r double dot will be equal to minus times mass times omega square r vector, and r is this, given by this very equation. Okay, so we will get this very equation like this. So mass times r double dot is the force from second law. Okay, using second law of motion, isn't it? So this will be equal to force acting onto this particle which is moving along this very path. So force will be given to as equal to minus times m omega square r. This will be the force applied onto this body, but we have to calculate what kind of nature of the force is, what kind of force is applied onto this very particle. So we have to discuss the nature of force F. So for that we will apply the curl upon this force, evaluating curl. You might have already done this very thing, curl of force. These are all simple problems. So curl upon this, what does curl is represented as delta cross F, and delta means in one dimensional motion, delta is equal to d something by with respect to x. That is the differentiation of that very quantity with respect to x. In two-dimensional, it is dx by dt plus dy by d of something by dy. That is differentiating with respect to x, and then again differentiating with respect to y. And here in case of this, we have to say, for example, we have three-dimensional case, and the curl in three-dimensional is given to will be 0, and this will also be 0. So that means the whole curl of the force will vanish. Okay, that means the curl will be curl of f will vanish. What does that mean? And this is the mathematical formulation of conservative force. Mathematical form of conservative force, that is if the curl of the force is vanished, that means the force is diverging. It is not curling, okay? It is not rotating. It is not curling around the point particle. Okay, that means the curl is vanished. That means it gets diverged. It is like this is the point particle here. The force comes out like this. This means the force is diverging. If it would have been like this, then there might be some curl present inside a particle. So that means the curl of the force is vanished. That is the mathematical formulation of the conservative force. That means the force is conserved. That means the force which we were discussing along the sinusoidal path, along the curve, which was given by R equal to cosine of omega t and sine of omega t, that very force is actually the conservative force. That means the work done by this force will be independent of the path. That is the outcome of this conservative force of the path which it follows. That means the force which we were discussing here, it is conservative in nature. That is the curl of the force vanishes. Okay, this was a simple example. Hope you revise it 2 times if you not get it on the first instance. Okay, so for that you will get this idea about solving the problems like this. I will be dealing with other examples in the due course of time. With that, I'm going to finish it. Please comment in the comment section if you feel any difficulty in understanding this very problem. I will come across those very queries soon. Hope to see you in another video. For now, God bless.